Hello, my name is Amaru Zeas-Sigüenza, filmmaker and creative director for Griptape at Foundry. As a solo filmmaker, I created 120 cinematic 4K shots in only 8 days, using traditional DCCs and Griptape generative AI workflows. In this breakdown, I will show you how I kept consistency, detail, and creative control across the entire project. But first, let's watch a sneak peek. The film needed a way to turn a written story, a script, and production brief into connected visual sequence. The journey begins with a project PDF, which becomes the foundation for the entire creative system. The PDF document carries the film's context, story, script, sequences, storyboard notes, technical details, and shot information. Agentic AI flows extract that information and turn the written material into structured, creative context for the pipeline. The agent reads the story information and generates the shot prompts needed to begin crafting the visual sequence. Those prompts move into image generation models, creating the first storyboard frames from the same narrative foundation. The same project logic can travel through different generation paths, including open source models and proxy models, depending on the creative need. As the first storyboard sequence develops, individual frames can be selected, revised, inpainted, or adjusted with a more targeted creative control. The generated storyboard frames move into Nuke Studio, where the sequence takes shape through the timeline editing, where you can add sound effects and music. The film needed a driver that could match the tone, danger, and rally-era personality of the rally car. A loop-based workflow generates a wide range of driver profiles from the same creative direction. Inside the loop, an agentic flow uses basic rule sets to guide variation while keeping each result connected to the film's tone. Each iteration explores different faces, ages, ethnicities, expressions, helmet suits, and character energy. The generated prompts move forward into the image generation flow. In this example, the system produced around 70 different drivers. From there, the artist selects the driver that best fits the story. The workflow turns character generation into directed casting process, where AI expands the options and the artist makes the creative choice. After generating a strong set of driver concepts, the next step was to make sure the character pool had the right range of features, identities, and variations for the film. This workflow enhances the character generation process by reviewing the full set of generated results and identifying what characteristics are still missing. Once the system recognizes a gap, it automatically creates new prompts designed to expand the set in a more complete and meaningful way. In this example, the workflow began with a group of 5 female-only characters. The agent recognized that male characters were missing from the set and started generating new driver options to fill that gap. This creates a more automated and intelligent process, where the workflow builds a more complete and production-aware character library, helping the film move forward with a stronger variety, smarter automation, and better creative coverage. Once the driver is selected, the film needs a full character design that can carry the racing suit and the visual identity into the next stages of production. Local models such as Flux 2, enhanced with LoRa's, help generate and refine the full body design with strong control over style. Cloud models such as Nano Banana can also be used in the same creative path, giving the artist another way to refine. The different outputs then move into a traditional DCC or paint workflows where the artist can do paint overs, fixes, and cleanup. From there, an agentic flow analyzes the final character image and generates a structured text prompt for a full character sheet through local models or cloud models, depending on the level of control, speed, or quality needed. The final stage moves forward into traditional DCC and paint refinement, where the artist adds the last layer of craft, realism, and design polish. A single selected driver evolves into a full production character, ready to support 3D, shot blocking, video generation, and continuity across the film. The film's hero asset needed a strong technical foundation so the Lancia Delta S4 car could carry its realism into the film. The process begins with a PDF containing highly accurate information about the car, including dimensions, weight, etc. Then an agentic flow extracts that structured data, turning into text prompt for generating accurate blueprints of the car. One path uses the blueprints to generate a low-poly 3D mesh, giving the production a lightweight car asset that can be used across previs, layout, shot planning, etc. A second path carries the same blueprint set into a traditional 3D DCC, where the front, side, top, and rear views can be placed on image planes for more precise 3D modeling. From there, the car can be built through a more traditional production workflow in tools such as Blender, Maya, or other 3D DCCs. The car also needed simple driver geometry inside the cockpit to guide later image and video generation. The selected character sheet is set into 3D generative model to create a low-poly texture driver and core driver. A very basic rig is added so both drivers can be quickly posed and placed inside the rally car. The Delta S4 car evolves from written specifications into usable 3D production asset, giving the film a strong hero car that supports previs, shot generation, layout, and traditional modeling with such stronger consistency and control. The flow begins with a base prompt, and an AI agent turns that context into stronger environment brief for the scene. The photo batch node is then used to sketch the composition, block the road and landscape, and guide the overall visual structure. That rough draw over becomes a creative guide for the generation step, adding more intentional art direction to the image. A Nano Banana node then generates the final background from that guided input. The workflow shows the progression from rough visual blocking into finished generated environment. In this specific shot, I wanted the car to extremely close to camera and barely miss the tree trunk. While generating the previous image can be used on other parts of the pipeline, for this specific example, it did not quite work. Without full 3D scene context, video generation struggles to understand the exact spatial relationship and timing. Then, we enhance the shot production by jumping into 3D space. The low-poly 3D car created earlier becomes the starting point for the shot layout. A simple text prompt is used in Griptape to quickly generate a 3D tree trunk asset for the scene. Both 3D meshes, the car and the tree trunk now, move into Nuke. This gives the artist much stronger control over camera angle, camera position, and composition. Now in Griptape, we combine all assets. Griptape has an amazing feature called widgets, where you can easily vibe code any UI and host it into a node. For this project, I created a camera widget with camera parameters, giving the shot more intentional framing and lens direction. That camera data connects into an agent, which translates the setup into structured JSON prompt. From there, the pipeline assembles all the key ingredients for the shot: the Nuke layout, the 3D scene, mocap, the previously generated image, and the CGI render of the car. Those elements feed into an image generation model, where the shot begins to come together as a more unified visual result. The video model needed clear motion guide before the final generation. In Nuke, animation stays simple, more like layout or previews, focused on timing, direction, and spatial intent. The goal is to provide enough movement context for the video generation model to understand the shot. In Griptape, the workflow brings together the CGI car render, the generated still image, and Nuke animation paths. The generated video becomes the full render shot with much more control over the final result. The shot then moves forward into Nuke for traditional compositing and final polish. To create a strong Gaussian splat, the workflow first needs a high-quality environment image that matches the rally world of the film. A custom widget node connects to Google Street View, allowing real locations to be explored and captured from different angles in real time. An agentic flow analyzes the image and creates a text prompt that describes the scene and prepares it for image edit generation. The image and prompt move into local image models to generate several environment variations. In this example, the goal is to transform the sunny clear location into snowy winter rally stage, creating the visual foundation needed for Gaussian splat generation. Once the first winter environment was working, the next step was to scale that look across multiple location images while keeping the set visually consistent. Griptape uses a loop workflow to grab all the curated clear sky location captures from Google Street View. Each image moves through the same transformation process, using an approved winter reference image and text prompt as the guide. This allows the workflow to batch convert an entire set of sunny images into snow rally environments. Traditional tools such as InPaint or OutPaint can then refine specific frames and give the artist more curated control where needed. Once the images were ready, the next step was to turn them into spatial environment for the shot. Griptape uses WorldLabs to generate Gaussian splats from different inputs, including text, video, or images. Once the splat enters Nuke, the next step is to shape it into a control environment. Nuke gives the artist many tools to refine, reposition, and crop the splats to fit the set dressing needs. A bounding box makes it easy to control the modifications of the splats. Multiple splats can also be moved and combined to build a stronger environment for the sequence, giving the artist a stronger environment control and better foundation for camera animation. The next step is to balance their look so the combined environment feels cohesive. Nuke allows direct color correction on the splats, giving the artist control over brightness, color, and overall match. The splats blend together more naturally, creating a stronger and more consistent environment for the shot. The shot needed stronger camera control before moving into generative image and video workflows. The low-poly rally car created earlier is brought into Nuke for composition reference. The artist can place the camera, adjust the angle, and frame the car like a traditional 3D or live action setup. The goal is to create a set of controlled still frames that refine the shot before sending them into generative flows. The still frame moves from Nuke into Griptape, where an image-to-image flow is used. The blocking image becomes the foundation, preserving the camera angle composition and adding the realism and fine details. The shot needed a smooth camera movement with enough flexibility to iterate quickly on motion and framing. Nuke makes it easy to animate the camera directly inside the splat scene and start shaping the shot in motion. We can use splats resolution as LODs as needed. The shot now comes alive with fully controlled camera motion. Now we need to combine all the generated assets into one controlled generation flow. The process starts in Griptape with the same custom widget camera carrying the camera direction into Agentic prompt flow. The agent outputs that structured shot instructions for the video generation stage. Then the flow combines the control image from Nuke, the animated splat camera pass, and the 360-degree CGI render of the car. Those elements fit into generative AI video models, giving a stronger control shot. The generation video then moves forward into Nuke for the final compositing pass. The film needed an automated way to find specific visual mistakes before moving into cleanup. This agentic flow reviews every shot and frame across the full film, searching for a repetitive issue, in this case an incorrect logo appearing on the windshield. The system curates only the frames where that mistake is detected, turning a large review process into a focused repair list. The workflow turns 120 shots into an organized set of targeted fixes, ready for logo removal and final cleanup. Now in Griptape, the goal is to remove the incorrect logo while keeping the original plate almost intact. The workflow begins with the original plate and a track mask created in Nuke around the incorrect logo. That plate and mask are fed into a multi-minimax object removal flow, which uses the mask to target only the area that needs the cleanup. Another way to do cleanups is with vector distort or smart vectors. A cleanup section is taken from a frame where the strap is clear or hidden. That clean patch is isolated and merged back over the original plate. As the strap appears across different frames, additional clean patches are layered into the repair. The patch is processed through vector distort using smart vectors, so it follows the motion and contour of the shot. This allows the repair to move naturally with the plate instead of feeling locked or static. The same technique is repeated across the frames until the artifact is fully removed. Traditional Nuke compositing preserves the shot and gives the AI-generated footage a cleaner, production-ready finish. Using Nuke Stage, the car can be placed directly inside a Gaussian Splat world and viewed as part of the shot space. This creates a stronger bridge between spatial environments, hero assets, and camera-driven shot design. The splat evolves into a virtual production stage where the world and the car can come together for more directed shot development. Foundry machine learning tools can extract different AOV passes to later use on compositing. Those extracted passes can then move into AI pipeline as guided for diffusion models, cleanup, or targeted shot manipulation. In this example, that same approach supports a more traditional phase replacement workflow inside Nuke. Using LTX 2.3 with LoRa, the workflow converts the original SDR image into HDR-style EXR output. Inside Nuke, both the original PNG and the 32-bit EXR are compared using the same exposure setup for a fair evaluation. When lowering the exposure, the EXR keeps more highlight information, especially in reflective areas like the helmet. The process also improves detail during the conversion, with stronger reflections and cleaner image information. The shot gains more dynamic range and more flexibility for final grading and compositing. Inside Nuke, the different color nodes are balanced to shape the final look of the shot. The goal is fully creative control, adjusting the generative image like production footage with mask, grades, and targeted refinements. Segmentation masks allow specific areas like the driver's face, eyes, or helmet to be isolated and adjusted independently. Depth maps add another layer of control, helping create atmosphere, separation, and extra cinematic depth. The shot becomes fully customizable inside the VFX pipeline, combining generative AI with traditional compositing control. This is a hybrid workflow that connects CGI, generative AI, video AOVs, and Nuke compositing into one final shot. The process starts with the traditional CGI 3D AOVs. Those render elements move into generative AI to build the background. The generated result is then used to create the generative video shot. A custom leitmotif image that I created acts as a visual map showing the intro, transitions, and all 6 rally stages of the film. A custom music widget adds controlled audio parameters similar to the camera widget used earlier in the pipeline. The leitmotif image is analyzed to extract key musical cues and structure information from the visual layout. That information is combined with the settings from the music widget and passed into an agentic flow. A rule set gives the LLM more guidance, helping translate the visual and musical inputs into stronger soundtrack prompt. The workflow can generate multiple music generations in one pass. The film gains a structured way to generate and compare multiple soundtracks directions, all grounded in the narrative flow and emotional arc of the project.